This screencast is to show how to use algebra tiles to solve equations that involve parentheses. These can be a little confusing, but if we can understand how to set it up with algebra tiles first, it'll make it easier to not use algebra tiles later, which I will be showing in a moment. So first of all, let's look at this equation. You also have to think about how to say this. Immediately we want to say 1 minus parentheses 2 minus 3x parentheses. Technically in math we're supposed to say 1 minus the quantity of 2 minus 3x is equal to 2 plus 2x minus the quantity of negative 1 plus x. Alright, so let's start with this. The left side is an expression and we want to equal this expression on the right side. So let's set up this one. 1, we know that's 1 unit tile, and there's no parentheses, and it's positive 1, so let's just put that here in the positive region. Now, here's the key. Minus the quantity of 2 minus 3x. Everything here, that's this expression in the parentheses, can be put in the negative region because there's a subtraction sign outside of the parentheses. So we have a 2. And it's a positive 2 inside the parentheses. Here we have 3x, but it's a negative 3x inside the parentheses. We're just focusing on inside the parentheses because this negative sign shows us that it's all in the negative region. So let's do it, minus 3x. So this right here would be plus 3x, but we want minus 3x, so just click it. And then we're on to our next one, 2 plus 2x. There's 2. 2x minus the quantity of negative 1 plus x. So once again, whatever is in the parentheses, I'm going to put what's in the parentheses in the negative region. So that's a negative 1 and a positive x. Alright, from here you have a few options. Well, actually not really. Well, yeah, on the right hand side I could see something we could do, but technically it'd be nice to flip everything from the negative region up to the positive region. We could do that here as well, or since this x and this x are same tiles but different region, this could actually be positive x minus positive x. That's going to cancel, I know it. And you'll see why it's going to cancel, because when I flip it up, I move it to from the negative to the positive region, but then flip it over, you can see that makes us a 0 pair. So just like how same tiles, different region are a 0 pair, well, these are different tiles, same region, or different signed tiles. So that 0 pair makes it go away. Let's bring all these up. And the reason that this works is because this is 2 positive tiles that were in the negative region. Well, I distribute this negative sign to the 2, which makes it negative 2. Well, that was negative 3x in the negative region. Well, the opposite of negative 3x is positive 3x. Okay, from here, we can see there's a 0 pair here. Bring that off the board. I can see there's a balanced set of an x tile here and an x tile there. So a balanced set can be removed. And now we're here. Well, I want to find out what x is. So to do that, I'm going to want to get 2x by itself. So this is kind of in the way. This is 2x minus 1. So what can I do? Well, I can add a balanced set of one positive unit tile to this side. But if I do it to this side, I must do it to the other side. Therefore, we have a balanced set here. And finally, we have 2x equals 4. We should be able to see how to do that, but if we don't, we can see that this 2x can be divided into 2 equal groups, while this 4 unit tiles can be divided into 2 equal groups. So we can see that if 2x equals 4, then 1x is equal to 2. Therefore, we can remove this, showing us that x is equal to 2.